Okay. So if you thought that we're gonna speak about infrastructure, we won't. We won't say anything about requests or tooling maybe. We won't show any live demo because it's always a disaster. We want to talk about consistency that is needed to manage frontend effectively. In monolith times, everything was under developers' control, yet maintaining consistency was still hard. Every controller had its own view and its own dependencies. Chunks of view code was repeated again and again and full of logic. So does microservices architecture solves anything or changes anything then? In distributed environment, old problems still apply, and they are even more complicated now. Duplicated dependencies, page element conflicts, inconsistent view, including page fragments, and so on, so on. So how to beat so many problems with maintaining consistent frontend? We are going to present you our approach and show you the main problems we had to overcome. We'll try to convince you that squeezing frontend into one place, something like components registry, is a good decision to make. So again, I'm Bartosz and this is Krzysiek.
Hello.
We are working together at Allegro company, and our mission is to reinvent our microservices frontend. We will focus today on three topics that are data and view separation, page definition, and multiple view forms. And after that, we hope to summarize everything so you could go home and with some thoughts to think about.
So to start thinking about managing frontend in a context of microservices-based systems, we must be sure to know what frontend is and how you define your frontend. And to make it simple, to start it simple, frontend is a frontend. It what provides you an interface to the system. Underlying complicated system is hidden behind it in that interface. Frontend is everything that's directly involved in making and serving you a page that you can see in your browser or in a mobile app. Everything hidden behind frontend is backend. Simple as that. And in my opinion, in a tangled reality of microservice-based systems, it's very important to draw a clear line between backends and frontends, and to identify frontend and keep it in one place. It's very important to be very strict in that topic, and I'll tell you why. For example, if every service talks HTML, then our frontend is spread across multiple services. Like when one service is returning like a list of items and another one is returning list of top 10 items, everything in HTML, of course, and so on and so on. And we are and in this environment, our mission is to produce a reasonable to produce a page to combine these parts in a reasonable way. Then basically we are doomed, because assembling these chunks of HTML returned from the services is simply like concatenating the strings. And what's wrong with that? We don't have a knowledge what's in there, because those responses have no structure. It's just HTML. HTML is a text. We don't operate on that level. We don't know if it's safe to, for example, combine two services, because to combine these two things together, we don't know if they still work if combined, because they might, for example, require to be placed in a given order, or they depend on a given HTML structure, or maybe they will break if one of the services forgets to close an HTML tag or adds a one by mistake. And another thing that another issue with the services that returns HTML is that there is no reasonable way to manage front-end assets. References to the scripts and styles are hard-coded in the responses. So tasks like managing overall user experience, styles consistency, designing some sane scripts interactions are very hard, if not impossible, to complete. One service can easily introduce styles, for example, that breaks whole page, and if you don't have any control, you don't have any way to control that behavior, because when you are assembling the generic HTML written from the services, then, for example, style tag is just another tag in a tag soup returned from the service. And scripts, another example, scripts operates on a global scope. So when, for example, two services returns the same looking item like carousel, and they have one have carousel.js and another one has carousel.js too. They may be in a slight different version. They may conflict in a global scope of JavaScript namespace. And in this setup, you must believe that that these services, these HTML providers are good citizens. They apply all your design, UI style guides, because you have to believe because you don't have a way to validate if they are okay, and you don't have a way to force this, for example, style guides. And remember that the page view logic is spread across tens or maybe hundreds of underlying services. If one fails, what should you do? And if you have ever played with the server-side include-based systems, so maybe you had used varnish cache as a page assembler, and if you had a large number of separate services that returns its own HTML, then you know what I'm talking about. But if you haven't, then just remember that at scale, server-side include-based systems hurts. But if the services gave us only a data, if they can stay data only, and then they can focus on what they do the best, so providing the data efficiently, the business logic, and leave all this presentation stuff, all this messy markup stuff behind. But if our services are our backend, then who will generate HTML? One brave service must accept this burden. A service that can produce a readable content to the user. A service that knows how to transform the data into final page markup, maybe with some help of like view galleries. A service that basically take care of all your front-end related stuff. Profits of this separation are obvious. We can centralize our front-end experience in one place, so have it in one place. We don't have to implement the same views all over again in separate services. For example, if the service returns some kind of product list, we have to do it only in one place, and we can operate on the data because it's structured data on this level with ease. We don't dealing with some weird tags HTML soup anymore. And in our case, the page assembler service is opbox. Its responsibility is to gather all the data from the backend microservices and integrate them into a single user experience for a user. And to do so, it has to know what the user should see after typing the URL in the browser bar. So it must find the page definition, find the matching page definition, then fetch all the data from the data sources that is needed to produce that page, and then render it using maybe some kind of components. It's a typical content management stuff, yes. And yeah, opbox is like CMS, but for microservices. And now Bartosz will have a few words on page definition that are the heart of the opbox domain.
Yeah, and in the middle of the project, I have asked myself, who could possibly think that something is like page definition can be so hard? We were aiming for logicless page configuration and to be as generic and flexible as possible. So, what is the page definition? Page definition is basically page structure and microservices that are combined just to make your page alive. So, page structure is a tree of building blocks. We like to think about them like boxes. Boxes are abstract user interface fragments which will be transformed into view later. They're only representing user intent about the page layout. Also, we have some REST APIs. We call them data sources. And basically, it's a bunch of services that you want to use. But it's never enough flavors. For example, depending on user behavior, we want to hide some page fragments or simply show a different one. So we thought that bringing up some simple conditions like date triggers or something like that will be enough. But we ended up creating our own expression language. For example, if you need to take one service to be an argument to the other service, or maybe you need a little bit of customization of the data before passing it to render. It's the place for simple logic rendering your service data. Also, we've made an administrative app where you can create a set of pages and give them live using provided data sources. Also, we made some tooling for developers for easy way to create new boxes and defining the data sources, which can be used in our admin within a minute. And I'm sure you are curious to see what we can do with all those fancy things later. So Krzysiek is going to tell you about the next step.
So when we have a page definition, that, as Bartosz said, is a tree of objects called boxes, and boxes represents an abstract UI fragments, and we have data from data sources, the backend data sources, to power those boxes. Then all we have to do is to render. And in opbox we have a renderer that is responsible, that produces and serves HTML to user browser, and we have a native mobile libraries that allows you to embed the same page definition, view the same page in the context of mobile apps. The web and mobile have a different needs, so that's why this separation. But we want our page to be displayed on both the same page, the same data. Only presentation differs. We have focused on this presentation only on the first one, but keep in mind that the same applies to mobile. So to make multiple renderers possible, we've introduced another layer of abstraction. So internally, opbox is divided into a front-end, backend, and front-end frontends. Front-end backend service, opbox core, does the hard work of contacting the data sources, fetching the data, and resolving all the conditions to produce the final page structure based on data, based on these conditions. And what opbox core does, it hides the complexity of this microservices, of underlying services from renderers. It produces intermediate render form, the intermediate page render result, and this result is then an input to the renderer. The intermediate page render result is an object in a JSON format. It can be considered as a document object model for the renderers, and it's a technical detail. Don't focus on that snippets too much. But what is important in here is that the structure consists of the boxes, the structure, tree structure of boxes, and the data fetched from the services. We have all of this in one place, all the information needed to describe the page. And in page definition, the boxes, page definition operates on the boxes, and boxes, as we said before, represents only an intent, an abstract UI element. The box says, I'm a list, I should be displayed as a list, but it doesn't say how to transform its data into a final markup. It's the renderer responsibility to know how to do that, and opbox web, our web renderer, knows that because it has components. And in a way, you can think of components as a recipes, as a templates, the simple stateless function that transforms received data into a markup. It also provides useful metadata, like, for example, required assets to be added to the page to get the full visual effect. And single component provides UI experience for a single type of box in a page structure. And to render whole the page, opbox web breaks down all the page definitions, this tree of boxes, into a single boxes, and then one by one, box by box, part by part, it's using components, processes them into a final markup, which is then integrated into a whole page. But it's not like concatenating the strings, as I said before, because of the structure, because the fact that boxes are organized in a tree structure, we operate on the structure, and for example, boxes can decide decide on the presentation of the child boxes. So we have a control. It's not like operating on the strings. And another good part of that is that scripts and styles are processed independently from the markup. So they can be transformed, they can be optimized in the context of the whole app. Whole page.
So we can refresh the child, yes, from this structure. How we can
refresh?
Yes, when you want some block to be refreshed,
yeah,
child block. When we put some
mm-hmm.
data to the structure, and the frontend will know that some child should be refreshed.
We only rendering the we're rendering the result received from the layer above. So there can be some conditions. For example, you want to see a second page of particular box, yeah, but this can trigger a lot of changes in the structure, the whole page structure, because maybe, for example, the second page of some box, this carousel, maybe it's defined in page structure that then you should or should not display showcase above, or some kind of adverts that touch this second page and so on. So answering your question, when one data from that is needed to be displayed to display one box are changing, then we should process all the page, and then boxes components can decide if they want to update their state or not. So it's always in the context of the whole page. But back to the presentation. Yeah, so components doesn't care if the data come from one service or another. Component only cares if the data is if the data are in a format that satisfies accepted data type, so they can display it in properly. So we can easily switch the data source and have it rendered using the same box, the same component. Okay, I know that the component is an overused word in generally, but especially in programming. But in the context of the UI, I think it well describes the nature of things. Think of React, Angular, web components. The same idea, only the level of abstraction on which they operate differs. I think that the component-based app design, especially front-end app, are key to achieving consistency. And opbox takes the best of two worlds. It is centralized as a monolith, so for example, one team can work on the components and take care of UI consistency for all the pages. But regardless that is centralized, it delegates the rendering job to the small, well-defined, pluggable components.
Krzysiek once said to me that we have run out of simple problems. Just like the question, we have a lot of them, and they are hard problems really, but we won't focus on them today. Maybe next time we will share some thoughts about those topics. I would like to focus on what do we have today. We have created not only an app, but some kind of trend going on the company. We don't do any HTML concatenation. We provide front-end consistency. We provide that non-technical user can create page easily. And we managed to really separate model, view, and controller using the components registry. Okay, we broke some rules, by the way, but still, I think that some of you are thinking that this is nothing special. Yeah, maybe. We are aware of that big companies like ours came to the similar conclusions regarding microservices frontend, and we are not trying to be the original ones or the precursors. I don't know. We are only looking for elegant yet simple framework to work with, and we wanted to share our work with you today. And you know what? We are really proud what we've done so far. It seems that we've gone in the right direction, and I hope our organization sees it. And as I said, we are in production every day with more complex sites. And if you want to follow our progress, we invite you to our tech blog, where sometimes you can read about our works on opbox, and track our GitHub repos, when you can see the links on the slides. And this is all. Thank you very much.
Thank you.
And you're free to ask a question. Yes.
Okay, so I wanted to ask about response times. I want to ask about response times. So if you depend on all your microservices to return data before you render the whole page, it means that you will render no sooner but the slowest of your dependencies. Yeah?
Basically, yes. We put a lot of effort to make those requests parallel, so we don't have to wait really so much. But yes, we have something like our every data source, every REST service has its own, I don't know how to call it, definition, something like that. When you have to provide how long we will have to wait, then we can count it, make a sum, and then say, whoa, you cannot put this into this page because we will have to wait so much. Please don't do it. But it's still one of the problems we have to work with.
But it's not the only way to have a data on the page to get it there through the backend, because you can have a component loaded into the page, and then this component can connect any API without opbox. So you can have this experience that is like lazy loading and stuff. It's what should be in the data sources is the data that are needed to decide on the structure of the page. So, for example, if it's a page that displays a single item or it's a listing or stuff like that, and details can be fetched from independent APIs, like if they are slow, for example, or not needed for every page. So it's like that.
Okay, so there's no other questions?
We have marks.
Yes. But okay, anyone wants, so... okay, so you can always ask us personally. We will be here all the time, so thank you.